Now comes the fun part. So talking about batteries, right? So what's shown in this picture doesn't really look like much of a battery, but it generates electricity. Now batteries by themselves are spontaneous chemical reactions waiting to happen. And as soon as you connect something to the two ends of your battery, electrons can start flowing through that machinery and allowing the electrochemical reaction inside to take place. Okay? But until you connect those two ends, nothing happens because the electrons can't flow. Okay? So the way batteries work, and especially the pictures that we're showing you of these are called galvanic cells. Galvanic or voltaic cells. Okay? And by convention, we always put the anode on the left and the cathode on the right. Okay? And anode is always the oxidation side and cathode is always the reduction side. Okay? And the way you can remember that is that anode and oxidation start with vowels, and cathode and reduction start with consonants. Consonants. Okay? The other way that I figured it out before I recognized that part of things is that the word cathode has a positive sign on it, and the cathode is also the positive electrode. Okay, the other way to think about it is, my other favorite is the red cat. Okay, so, but the important thing is that the anode is on the left and the cathode is on the right. Okay, in any image of an electrochemical cell like this, anode is on the left, cathode is on the right. Oxidation on the left, reduction on the right. Okay, and electrons will always flow from the anode to the cathode. Okay? They always go in this direction. Right? So now, what's actually happening inside of our beakers is that on the left, we have one half reaction, and on the right, we have the other half reaction. In case you were wondering why we've been talking about splitting reactions in half this whole time, this is why. Because we are physically separating the two reactions, okay, in order to make something that generates electricity. Okay, so in this example, on the left, we have a piece of zinc in zinc ions. So down here in the solution, we have zinc 2+ ions because it's zinc sulfate. And on the right, we have copper, solid copper, in copper ions. Okay? So as the reaction happens, we have zinc solid becoming zinc 2+ ions. Okay? So quite literally, this solid zinc on the left-hand side, the solid zinc is becoming ions in the solution. So the anode side actually loses mass. Okay, because that solid material is breaking down and becoming ions in solution. Okay, every time some electrons go through that wire, some of that zinc is oxidized from solid to ions, right? So on the right-hand side, however, as electrons come in, we take a look at that reduction half reaction, we have copper ions becoming copper solid, right? So as electrons flow in, those copper 2 ions become copper solid. So the cathode side gains in mass. Okay, we're talking about the electrodes losing mass or gaining mass, those pieces of metal. Okay, so, and this will continue spontaneously until there's no more zinc, no more solid zinc electrode left over. And this is just like what happens in batteries of your cell phones or your laptops or your car, for example, is that you have an anode side and a cathode side. And eventually, the battery wears out because the anode side has been used up. And then in rechargeable batteries, like in your cell phones and your laptops and your car, if you apply some sort of external voltage, like you plug it into your charger, you can force the reaction in the opposite direction. So your cathode loses mass and you rebuild your anode. Fascinating stuff. Fascinating stuff. So in this electrochemical cell, the electrons will flow from the zinc electrode to the copper electrode based on this, which is true. So for flowing from the zinc to the copper, so remember that the left-hand side is zinc solid being oxidized to zinc 2+. So zinc is becoming ions. And on the right-hand side, we have copper 2+ becoming copper solid is a reduction. So oxidation on the left, reduction on the right. So we have copper ions becoming copper solid. So let's take a look at our answers here. So copper electrode will lose mass. That's not true. The ions in the salt bridge will travel to the right, the anions to the right, and the cations to the left. Well, we didn't really talk about that. Let's come back and talk about that really quick. So let's think about this. So looking at the left-hand beaker, okay, the left-hand beaker is building positive charge. Okay, I'm getting more positive ions in the solution. So in order to keep the charge balanced, I need negative ions to come in. So that's the point of this salt bridge, is that I'll have negative ions flowing out of the salt bridge. On the right-hand side, I'm building negative charge. Right? Because my positive ions are going away. Right? So in order to keep a charge balance, if I'm making more negative charge, I need my sodium ions to come in. Okay? So the salt bridge is there to maintain balance. Right? Because on the left, if my zinc is becoming zinc plus, I've got more pluses in there. So in order to keep the balance, I need to add more minuses. That's where the nitrate ion comes in, that negatively charged nitrate ion. On the right, as I lose negative charge because my copper 2+ is going away, it's becoming copper solid, I'm getting more negative charge, so I need to add more positive in there with the sodium plus ions. So let's take a look at our answers again. So now that we've addressed that. So the anions in the salt bridge will travel to the right and the cations to the left. Let's take a look at our example. So in our example, our negative ions, our anions, travel to the left and our positives to the right. So no. The concentration of zinc ions will increase. Take a look. So on our left-hand side, the zinc solid becomes zinc ions. So as this process goes, then we get more zinc ions. So that is a good answer. And the color of the copper sulfate solution will get darker blue. Well, the color is a result of the copper ions. So on the right, I'm losing copper ions to become copper solid. So if it were becoming darker blue, I'm getting more copper ions. So I've got less copper ions. So it will not become darker blue.